distribution, the event that involve perpuluhan or decimal places, 1.1, 1.2. So discrete means the event that only takes exact number. Okay, 1. How many times do you go to class? Okay, so you can see I go to class once a week or twice a week. Okay, there is no 1.2, 1.3. Okay, so, but what is your CGPA? Okay, what is the probability of getting 3.1? So in terms of if the data can take continuous number or decimal places, so that one will fall under continuous distribution. Okay, so for discrete, okay, the focus for discrete will be again, okay, binomial and Poisson, because these are two distributions that can only take exact numbers. Okay, what is the probability that that you will have, let's say, that you will own one house, okay, when you, or you can buy two houses before you retire. Okay, so maybe you want to buy one house also is already costly. So to buy two houses, maybe the probability will be much smaller. So, but you cannot say the probability of buying 1.3 houses. Okay, there's no such thing as 1.3 for exact number like bilangan rumah, number of houses and whatnot. Okay, so that is for binomial, and so we're going to cover briefly what are the characteristics of probability distribution. Okay, the difference between discrete and continuous. Okay, I already gave to you the basic idea what is discrete, what is continuous. Okay, and then compute the mean. Okay, but of course, this is just going to be very brief. Okay, so the focus will be on the remaining two here. Okay, so what is the probability distribution? Okay, so for the rest of the syllabus, okay, not only chapter number 4, okay, although the distribution, the table that the way the distribution is being displayed might be different, but the concept remains very similar. Okay, probability distribution is a listing of all outcomes, okay, of an experiment and the probability associated with the outcome. Okay, so the word distribution is a list, okay, or you can list down what are the probability that of all the possibilities, okay, or the probabilities if you do an experiment. Okay, so and then you take into account all of the possible outcome you put in the table. So that is what we call a probability distribution. Okay, and of course the simplest one will be okay, when you toss a coin. Okay, so in this example you toss the coin 3 times. So of course this shilling is not a Malaysian shilling, so this is from US. Okay, but whenever you toss a coin, let's say if you want to start the game, okay, the referee wants you to choose whether you want to start first or second. Okay, so is the common one is head or tail. Head is usually the picture of someone or the logo of someone. Okay, like in Malaysia, the head is usually the symbol of something. Okay, like the picture of Congkak or okay, or those kind of things. Okay, but in the US, the head is actually the someone's face lah, or the head of someone popular, okay, or significant. Okay, and the tail will usually is the value of the shilling, the 10 cent, 20 cent, 50 cent. Okay, so when you toss the coin 3 times, there's possibility of number of hits appears. Okay, so whether you get 0 out of 3 times, you do not get the hit. Okay, only the tail. Okay, 1, 2, or 3. So this is a simple idea of a probability distribution. So when you toss the coin 3 times, okay, you might get the first time you get tail, and tail. Tail means the back of the head, meaning the one that shows you the value of the coin. Okay, 5 cent, 20 cent. Okay, whether you get 3 times tail, meaning 0 hits, and or some other combination. Okay, tail, head. Okay, and then you calculate what is the number of hits from each of the possible outcome. Okay, so when you account for all possible events, you put in a table. So that is what we call as this probability distribution. Okay, So first, the characteristics. Okay, the outcome must be between 0 and 1. Whenever you talk about probability or the proportion, okay, you cannot exceed 1. Okay, the outcome is mutually exclusive. Okay, what it means by mutually exclusive event. So you may not be using this term a lot, okay, but at least in terms of statistics, okay, the term mutually exclusive is that the event of okay, for example, like this one, okay, when you toss the coin 3 times, okay, even though you get fail the first time, okay, does not mean that you will guarantee to get hit the second time. So what happened in the first time will have no influence on the outcome of the second time when you toss the coin. The same as the third time. Okay, so meaning that what happened in the first time does not influence the outcome of the second, and the outcome of the second will not influence the outcome of the third. So everything is random lah, nasib lah. Okay, so just like when you go, if you predict what is the color of what is the brand of the car that you see on the road. So let's say you are standing on the road, okay, on the roadside, okay, and then you want to guess, okay, the next car will be model Honda, the next one will be Proton, the next one will be Pro Duo. So just because you get that you see a Proton the first time, there is no guarantee that the second time will be Proton as well. Okay, so what happens the first will not influence the second time. So that is what mutually exclusive. Okay, and then when you the sum of all the probabilities will always be equals to 1. You cannot get more than 1. Okay, so probability will not exceed 1. Okay, it's between 0 to 1, 0 0.1, 0 0.2, 0 0.9. Okay, but you will not get more than 1, 1.1. Something wrong with your calculation if you get more than 1. Okay, so the case that we got just now, the number of hit that you get. Okay, so how do you get 1/8, 3/8, 3/8, 1/8 here? Is you just refer to this one. 0 hit, 1 out of 8 possible time. Okay, but if you get hit 1 time, 1, 2, and 3. So 3 out of possible 8. So that's why you get 3 lah. Okay, the same thing here. You get hit 2 times, also 3 times. 1, 2, and 3. So twice appear 3 times. Okay, so that's how you convert this into probability outcome, and the sum will always equals to 1. So that is probability distribution. Okay, so how you do an experiment, okay, as simple as tossing a coin, okay, and then you construct a simple distribution table, okay, by I mean you try to see what are the different possible outcomes, okay, from that experiment, and convert that into a simple probability distribution table. Okay, so that is probability distribution. So random variable, okay, a quantity resulting from experiment that by chance can assume different values. So the word random is rawak lah, meaning okay, whenever you do an experiment, okay, whatever outcome is random. Okay, so if you play a game like Monopoly, okay, or whatever board games, okay, and you get a dice or two dice, okay, and you throw the dice and you want to see okay, you want to see what are the numbers that appear on top of the dice, dadu lah, dadu, and you want to see what numbers do you get. So tossing the dice, okay, 1 times, 2 times, okay, the number that appear on top of the dice is totally random. You cannot influence the outcome. The first time you throw, you get 6, 6. Second time you will also get 6 and 6. So there is no so that is what random variable is lah. Okay, possible. So it's the same thing here. Okay, so these are all the possible events that when doing an experiment by tossing the coin 3 times. Okay, so again, the focus of our chapter number 4 will be these two, okay, discrete and continuous. Chapter number 4, we have 2 distribution, binomial and Poisson distribution. Both fall under what we call discrete distribution. Okay, because the event can only assume discrete number. Okay, discrete again, exact numbers 1, 2, 3, 1, 2, 3, 4, 5. Okay, so whenever you do an experiment, the number of events can only take exact numbers, okay, or clearly separated values, 1, 2, 3, 4. Okay, whereas continuous, okay, the event can also whatever the experiment that you do, okay, can take continuous number or decimal places, 1.1, 1.2, 1.3. Okay, so that is the main difference. So under continuous distribution, we will cover the normal distribution in your syllabus. Okay, so if you look at the syllabus, it will cover from chapter number 5 under continuous. So this normal distribution, okay, so chapter 9, sampling, confidence interval, these are all related to normal distribution. Okay, so just to give you an idea of how the syllabus are designed. Okay, so chapter 4 that we are discussing this week and also next week will focus solely on the discrete distribution. So only one chapter is discussing on discrete. Okay, so the number of students in class, the number of children in a family, the number of cars entering car wash. So these are all exact numbers. Okay, so the one that, okay, again under this discrete distribution. Okay, and then versus the opposite of discrete, which is continuous random variable. Okay, so it can take the decimal places. Okay, the length of song, so 1.2 minutes, 3.2 minutes, 4.5 minutes. Okay, the weight of student, so the weight of the student can be, okay, it can also take decimal places, 45.6 kilogram. Okay, 52.3 kilogram. Okay, the temperature outside. Again, these are all numbers that can assume decimal places. So as long as the event, the value or the variable that you are referring to can take decimal places, so that will fall under continuous random variable. If the variable can only take exact numbers, the number of children, the number of rooms in a house, okay, the number of cars on the road, so those are all exact numbers. Okay, so that is the difference between discrete and continuous random variable. Okay, so whenever you do an experiment, okay, just like tossing the coin 3 times just now, okay, just like in chapter number 3, okay, you can calculate the mean and also standard deviation of a series of numbers. Okay, so it's the same thing here. Okay, whenever we perform an experiment, okay, from an event, I mean from an experiment, you can also calculate what is the mean of the probability distribution. Okay, and also what is also the variance and standard deviation of that experiment. Okay, so that's why we learn the simple approach of calculating mean and standard deviation. What is mean? Okay, what is variance? Okay, measure of the spread of your data, the dispersion. Okay, so whenever you do an experiment where you can calculate what is the probability, okay, the mean of a probability distribution is obtained by the summation of x, okay, random variable x multiplied by the probability of x happening. Okay, and then you take the sum of all the possible outcome, just like the tossing the coin just now, you will get what the mean value. Okay, so for example, this is a simple probability distribution. The probability of selling cars on a particular day. Okay, so this is again just a simple experiment. So probability of selling 0 cars, okay, 0.1. Probability of selling 1 car on a particular Saturday is 0.2. Okay, until if you can sell 4 cars, is 0.1. Okay, so in a car shop, okay, in a second car shop or company, so you can imagine the kebarangkalian or the probability of selling 0 car in one day, in one particular Saturday, or 1 car, 2 cars, 3 cars, or 4 cars. So this is the associated probability for each of these event. Okay, 0 car, 0.1, okay, and the sum is equals to 1. Okay, so the formula for the mean is simply x multiplied by px, and you sum all of the possible outcome. So x is this one, this is the x, this is px. So x multiplied by px, okay, plus x multiplied by px plus x multiplied by px. So you repeat the summation for all possible outcome, then you can calculate what is the mean. Okay, so the mean here from this simple example is 2.1. Okay, so here of course you need to calculate this manually in your calculator, because I don't see how the online calculator can do this. Okay, but should be no issue. Okay, previous students, when learning face to face, they don't even use online calculator. So certain calculation you need to do manually in your calculator. Okay, whether your laptop calculator or your own actual calculator. Okay, so the mean is basically the sum of x multiplied by px. So for that particular event, selling cars on a particular Saturday, the mean will be 2.1, meaning 2.1 cars. The average value will be 2.1 vehicles sold. Okay, so this is the mean value of that particular Saturday. The mean value of selling vehicles on a particular Saturday is 2.1. Okay, so the same as before. Okay, when you calculate the mean, you can also calculate the measure of dispersion, which is the variance, and also standard deviation. Okay, and take note that whenever you talk about probability distribution, we always refer to this as the population symbol mu, and also sigma squared, meaning the formula for the variance. Okay, we don't use s squared, we use sigma squared, meaning the notation always refer to population symbol. Okay, so here is the formula for variance is summation of x minus mu squared multiplied by the probability of x. So here again, you are looking at the same data just now, x and px. Okay, and from the previous calculation, you know that the mean is 2.1. Okay, so the mean is 2.1. So x minus mu 0 minus 2.1, you repeat the process for all the possible outcomes until 4 cars, and then square this value. And then from this, you multiply with the probability of x, 0.1 here. So 4.41 multiplied by 0.1, you get 0.441. So you repeat the process for all possible outcomes. The sum will be the variance. Okay, and as usual, standard deviation is the square root of variance. 1.29 square root will be 1.136. So this is a simple formula or simple approach how to calculate the mean and also the variance and also standard deviation from a probability distribution. Okay, so again, the mean is just the sum of x multiplied by probability of x associated with each of the event. The sum will be the mean. Okay, and then the variance will be this formula, x minus mu squared multiplied by px. Okay, so you will get 1.290. Okay, as the variance. So by default, the formula is for variance. So once you get variance, you can take the square root of that to obtain the standard deviation. Okay, so that will be the formula or the solution for mean and variance for a probability distribution. Okay, so for next Thursday, okay, next Thursday we're gonna discuss on binomial first, okay, and then on the following week we're gonna cover on Poisson, okay, and we see whether we can finish chapter number 4 by next Monday, or if not, maybe we need to continue until next week Thursday, because the plan is in terms of the total learning time for chapter number 4 will be 6 hours, meaning for 2 weeks. Okay, but again, if the chapter we can finish earlier, then we can have more time for a much harder syllabus, meaning the topics later in the syllabus after the mid-semester break. Okay, after especially topic number 8, okay, 7, I think require more time, okay, in terms of the teaching. So I think for chapter number 4, hopefully we can finish by next Monday. Then we can start on chapter number 5, okay, by next Thursday. Okay, so I think that's it for today. Okay, I don't want to do any exercise yet for chapter number for this particular part. Okay, you can refer to the book in your ebook. Okay, uh, but then I think since the focus is mainly on binomial and Poisson, so I will focus more on that next Thursday. Okay, any other questions? So before that, okay, please do practice this thing again. Okay, from any question from the book, whether from the one with answers or the one without answers, you can compare your answers with your friends. Okay, since you are using the standard direct method from the calculator, so there should be no difference in terms of answer lah. Because what you do is just key in the data from your textbook, okay, directly into the website. So there is no supposedly no margin, there is no error that will come from your side. Okay, so I think that's it for today. Okay, inshallah